the Woolworth Sea Lever, an ocean current and tidal stream generator. The Sea Lever is a device designed to harness the considerable renewable energy resource held worldwide in ocean currents and tidal streams. Electrical output for a full-scale generating unit is predicted to be at least 20 megawatts, for a build cost of £36 million. This compares favourably with other renewable technologies and is comparable to non-renewable resources such as coal or nuclear. The Sea Lever can be used to generate power from any flow of water, which on a large scale means ocean currents and tidal streams. Ocean currents, such as the American Gulf Stream, the Japanese Kuroshio Stream, and the African Agulhas-Somali Stream, are continuous moving currents of seawater. The Gulf Stream has been estimated to carry harnessable power of around 65,000 megawatts. Tidal streams are flows of water moving due to the tide. The UK is estimated to have 15% of the global tidal stream resource. Viable sites include the Channel Islands, the North Channel of the Irish Sea, and of particular interest, Pentland Firth in the north of Scotland, where potential resources of over 6,000 megawatts have been identified. In June 2009, 20 companies completed bids for the first commercial tidal stream power generation leases in the Pentland Firth. This will lead to the establishment of a regional power grid, infrastructure and engineering skills base, backed by agencies including the Scottish Government. The power in tidal stream is most concentrated in narrow channels and around headlands. 4 times a day, as the tide ebbs and flows, power can be extracted. The power is predictable and consistent for months and indeed years ahead. The Sea Lever is composed of 2 major components, the capture float and the base. Taking a cross-section through a stream or current, the greater the area of flow which passes across a capture device, the larger the possible amount of energy captured. In the Sea Lever, the full submerged height of the float sweeps across the flow, giving a very large capture area. The cylindrical float is anchored in the flow, free to rotate around its axis. The flow pushes the float over at an angle. The float buoyancy attempts to move it upright in opposition to the flow. The flow past the cylindrical float produces alternating low pressure areas downstream, in an effect called vortex shedding, which moves the float from side to side. This combination of forces produces a continuous figure 8 type movement in the float. At the base of the float, below a rotational pivot joint, the continuation of the Sea Lever shaft moves around a bowl-shaped assembly, acting with a large mechanical advantage. The assembly contains hydraulic actuators, which depress as the lever end runs over them. This transfers the movement of the lever into hydraulic power, which is stored using an accumulator. The stored hydraulic energy is used to run generators, producing electricity. All components of the system are off-the-shelf solutions, relying on existing tested technologies. Marine architecture of this order of magnitude is currently constructed and installed by the oil industry. Indeed, the inspiration for the design is the unwanted movement of oil rigs and spar buoys. This means the construction of a full-scale commercial Sea Lever is already achievable using existing engineering techniques. Flume flow tank tests have been carried out at Coventry University in conjunction with Dr. Les Duckers. These tests have established the proof of the Sea Lever concept, and patents have been filed. Dr. Duckers has estimated the electrical power output of a full-scale Sea Lever as 20 to 50 megawatts. Build and commissioning cost of a full-scale Sea Lever is estimated at £36 million, costing 2 pence per kilowatt-hour of electricity generated. A smaller scale Sea Lever, suitable for tidal streams, with an output in the range 2 to 8 megawatts, has an estimated build and commissioning cost of £12 million, costing 12 pence per kilowatt-hour of electricity generated. These costs and outputs compare favourably with other renewable technologies and are of the same order as non-renewable resources such as coal-fired or nuclear power plants. Sea Lever is one of the designs of Woolworth Enterprises. Wilworth is a design and proof of concept company. It was formed by Ivan Williams, an established and innovative designer. Dr. David Slater, previously Chief Inspector for Her Majesty's Inspectorate of Pollution and Director of Environmental Protection at the Environment Agency. And John Hepworth, UK and European Patent Attorney. Wilworth aims to develop the sea lever design from the current proven concept prototype to a scale sea trial, and seeks partners to work towards this point and beyond to a commercial unit.